Dear students, welcome to the first lecture of Unit 1 in the subject of design of power electronic converters. In previous video, I have shared the introduction and the details about this course. So today we are starting with the first unit, analysis of power electronic converters. So in this unit, we will study in detail about how to design a DC to DC converter and H-bridge inverter. For DC to DC converter, we will focus mainly on buck converter. Then we will design the buck converter and then we will move on to the H-bridge inverter. So at the end of this lecture, you should be able to explain why a buck converter is required, what is the necessity of a buck converter, then describing the working principle of buck converter, to explain the on and off modes of operation, to derive the voltage conversion ratio, interpret important waveforms, understand continuous conduction mode. Okay, these outcomes are very important because this subject is not only for remembering or understanding the circuits, because we have already learned the converter in our second year power electronics subject. So here in this we are understanding how a practical converter is analyzed and how it is designed. Okay, so while watching on this lecture, focus on three things. Why do we need a buck converter, and how does a buck converter transfers energy from input side to output side, and finally how the output voltage is converted. So when you're watching this video, focus on these three things. So before going to the circuit, let's first understand where the buck converters are actually used. So these are few examples of buck converter application. It is widely used in electric vehicle, like high voltage battery systems must supply low voltage auxiliary loads. For example, EV is having a 48 volt for 100 volt or even 800 volt battery in EV based on the type of vehicle. But many control circuits, lighting system, this auxiliary systems require 12 volt, 5 volt, 3.3 volt, etc. So for that time we need to use a DC to DC buck converter which converts this 48 volt to this lower voltage as per our requirement. Then it is also used in computers and laptops. The inside a laptop motherboard, the processor, RAM, SSD, USB ports all require different voltage levels. So this buck converter helps to generate the lower voltage, which is a regulated voltage efficiently. Then another example is solar energy system. In solar charge controllers, panel voltage depends on the sunlight, but battery requires a controlled charging voltage, a fixed value, and the sunlight is varying continuously. So DC to DC converter is used to make this into the exact level what is required. Okay, so these are few examples of buck converter which is used in various applications. So here, if we have a 48 volt battery, we electronic circuit, suppose like if we need a 48 volt battery and the circuit control unit needs a 12 volt supply. Okay, so when we want a 12 volt supply from a 48 volt battery system, we need to design a regulator or we need to use a resistor to reduce that voltage. Okay, but when we have this method, it wastes a lot of energy. Okay, and a lot of power is wasted in the form of heat. Okay, so a buck converter solves this problem by using the high frequency switching devices. So instead of wasting energy, it transfers energy efficiently from the input side to output side. So this is the reason buck converter is preferred in modern power electronic system. So here, when you design a converter, okay, first step of the converter design is to choose the suitable power electronic topology. Okay, so for based on the application, you have to choose the proper power electronic topology. Okay, then understand the operation. So next step is to understand its operation. So which ideal power electronic converter is used for this particular applications, this is to be identified. So here in this course, as an introduction, we will analyze buck converter and H bridge converter, and we will design this converter. Okay, so when you design this converter, you are able to automatically design a boost converter and buck boost converter. So as a preliminary step, we will analyze uh, a buck converter and an H bridge converter in this first unit. So DC to DC converter is a power electronic converter which converts a DC from one level into another level, maintaining high efficiency. This block diagram indicates that. So the input and output are both DC. Input side is also DC and output side is also DC, but voltage level may be different. So DC to DC converter converts fixed DC to a variable DC. So for example, if you have a 24 volt DC in the input side, if the input is having a 24 volt DC, the DC to DC converter can convert it into a 12 volt DC. So this 24 volt is stepped down to a 12 volt. So this converter is called a DC to DC buck converter. Electronic devices require different voltage levels. So and battery voltage varies. The charging, discharging, based on the charging and discharging, voltage level may vary. So we need a circuit that can maintain a required output voltage even when the input voltage changes or load get varies. Okay, so for this reason, DC to DC converter is much more important. There are many advantages. It is having high efficiency, size is so compact, there is very reduced heat generation, and it is suitable for high power density systems. So the basic principle of a DC to DC converter can be understood by using this simple chopper. So actually what is happening, we are converting a fixed DC to variable DC. So we are having a fixed DC source and a load. Here for simplicity I have shown with this as a resistive load, and a switch is connected in between. Okay, so this is the fixed DC input. So Vs is the source voltage, constant voltage, and at the load side you can see the waveform like this. We are continuously turning on and turning off this switch. So when we are turning on and turning off this switch, when the switch is in on condition, the output voltage will be Vs, because when the switch is in on condition, this will act as a short and the entire Vs will appear across the output or load side. So the output voltage will be Vs, and when the switch is in off condition, this acts as an open circuit and the voltage across this load will be 0. Okay, so this is the basic waveform of a DC to DC chopper. I will explain it one more time. So a chopper works very rapidly switching a semiconductor device. Here we can use a MOSFET or IGBT for on and off at high frequency. When the switch is in on condition, the load is connected to the DC source. When switch is in on condition, load is connected to the DC source. Therefore, output voltage will be equal to the source voltage. When the switch is in off condition, if this switch is in off condition, the load is disconnected from the load. Therefore, the output voltage becomes, this voltage across this load becomes 0. So the output voltage is not continuously equal to the source voltage. Instead, it is a pulsed waveform. Source voltage is a constant waveform and output is like a pulsed waveform. Now, if this switching happens very fast, the average value of the output voltage can be controlled. That's why we are telling that input is a fixed DC and output is a variable or controlled DC. Okay, so the switching happens very fast. Average value of output voltage is varied, and the control parameter and the variation of this voltage is depending on duty cycle. So duty cycle is nothing but the ratio of the turn on time upon the total time period. So this much is the turn on time, and from 0 to this point is the total time period. So duty ratio is the ratio between 0 to t upon 0 to t on, this t on time period upon this total time. So this is the basic idea behind the switched mode DC to DC converter. If you observe any DC to DC converter, whether buck converter, boost converter, buck boost converter, basic principle is like this, switching is happening. So now we will see how it will act as a step down converter or step up converter or buck boost converter. So now we will move on to the buck converter in detail. A buck converter is uh, a buck converter consists of a higher DC input and the output will be lower DC value. It uses a high frequency switch along with a passive energy storage element such as inductor and capacitor. The switch controls the energy transfer from the input side to output side. As we have seen in the previous diagram, this switch will control the energy transfer from the input side to the output side. The inductor stores energy when the switch is in on condition. So when the switch is in on condition, this inductor will store the energy and the inductor will release the energy when the switch is in off condition. So remember this in your mind. Now the capacitor which is connected across the load, it reduces the output voltage ripple and it helps to maintain nearly a constant DC output voltage. So this is the need of the capacitor in this circuit. So the output voltage is controlled by adjusting the duty cycle of the switching signal. So in simple words, switch controls the energy transfer. This inductor smoothens the current, capacitor smoothens the voltage, and the load will receive a regulated DC power. So we are giving a constant DC power, load will receive a regulated DC power. So this is the circuit diagram of a buck converter. So I have indicated all the notations over here. Vs is the input voltage, S is the switching device. This can be a MOSFET or IGBT. D is a freewheeling diode. L indicates the inductor. C indicates the output capacitor. R indicates the load resistance. V0 is the output voltage. Is is the switch current through the switch. IL is the current through the inductor. IC is the current flowing through the capacitor, and I0 is the current flowing through the load.